Welcome to the lecture 4 on module 3 of Ocean Structures and Materials, a virtual classroom under the breath of NPTEL IIT Madras. This course had 2 modules already completed. Module 1 we discussed about varieties of offshore structures, coastal structures, their applicability, suitability for various water depths, their application and their construction form, geometric style, size, dimensions and etc. In module number 2 we also discussed about various types of construction methods and techniques, methods of laying pipelines. We also discussed about dredging equipments which are commonly used for coastal structures and cleaning etc. In module 3 we discussed about variety of material which are actually found suitable for application of marine environment. We discussed about the basic requirements of physical, mechanical and structural properties of material which are required, which are to be fulfilled for qualifying the material to be used in marine environment. We also discussed about variety of material like steel, concrete, metal and non-metals etc. and we also saw few classified recommendations given by various international codes based on which an engineer can easily select an appropriate material for construction of offshore structures or coastal structures. In the current lecture we will discuss in detail about concrete, problems and possible solutions which concrete has in marine environment. In the next lecture also we discuss about different adaptable methodology by which performance of concrete can be improved strongly. Marine structures are subjected to aggressive environment. Durability is subject of major concern especially in marine environment. Ocean structures are exposed to sea water directly, therefore coastal and offshore structures are exposed to simultaneous action of a number of physical and chemical deterioration processes. So this is an excellent opportunity for us to understand the complexity of concrete durability problems in reality, because the environment under which concrete structures are constructed in marine environment is highly complex. Therefore durability of concrete remains a major challenge as one of the important construction material in offshore structures. This lecture will discuss about some of the problems and solutions which can be adapted to improve the performance of concrete to particular to marine environment. If you look at different kinds of corrosion regions which are there in the marine sea state, the marine environment has 3 major zones which can be classified as corrosion regions or corrosion zones: submerged zone, tidal zone and splash zone. If you look at these zones as applied to a single simple concrete pile, as you see in this figure, the atmospheric zone where the corrosion is highly moderate is on the top. The splash zone is the portion which is slightly above the MHT, the high tide and low tide level, and the zone between these 2 tide levels is what I am addressing as tidal zone. The one which is below this is what I am addressing as submerged zone. So ladies and gentlemen, 3 major zones were atmospheric zone, tidal zone and submerged zones are area of concentration where we talk about corrosions on concrete piles. If you look at the atmospheric zone as one of the important aspect where corrosion can be studied, the corrosion in this zone is highly moderate. The main reason is there is a lower chlorine content and also presence of moisture. A severe corrosion takes place in the splash zone because of the reason of presence of abundance of oxygen and alternate wetting and drying process takes place here. Whereas in tidal zone high corrosion takes place, of course it is slightly lower than that of happening in the splash zone, but the corrosion is higher because of presence of chlorine and oxygen and alternate wetting and drying process, whereas the corrosion is much lower in the submerged zone because of depletion of oxygen as you go deeper and deeper. So a single concrete pile is subjected to variety of corrosion ranges within specific areas, which is a complex problem as far as any marine member is concerned. Concrete put to this as use has to meet lot of challenges, so that improvement of performance of concrete is one of the major focus what people address in the recent literature. Marine environment can be discussed in different zones or can be separated or classified in different zones as you see in the current slide. We talk about submerged zones, tidal zone, splash zone and atmospheric zone. The submerged zone is below the surface of water. The surface of concrete structure in this zone is constantly exposed to water, whereas in tidal zone it is limited by the extent of tidal actions only. It is site specific, depends on the sea state in a specific site where the structure is being executed. The surface of concrete structure in the zone is exposed to seawater in a very interesting manner, it is a cyclic manner. So, there is an alternate wetting and drying takes place in the zone, which is more dangerous for concrete performance in such an environment. When you talk about splash zone is limited by the extent of splash from breaking waves above the tidal zone. The surface of concrete structure in this zone is randomly exposed to seawater, because it depends on what is the extent of splash you have from the breaking wave above the tidal zone, whereas in atmospheric zone it is limited by the extent of spray from the breaking wave above the splash zone, so highly limited, and the surface of concrete structure in the zone is randomly exposed to spray from breaking waves. Therefore, the corrosion in this region is far lesser compared to the top splash zone and tidal zones. However, the corrosion in the submerged zone is further lesser because presence of depletion of oxygen in this segment. If you attend the submerged zone in detail, reinforced concrete structures which are particularly fully submerged in seawater are especially prone to corrosion of reinforcing steel due to variety of reasons. This include high chloride concentration present in deep waters, wet and dry cycling of concrete, high moisture content and oxygen availability. There are many factors which will contribute to corrosion even in submerged zones where concrete is either partially or fully submerged. Talk about the tidal zone is characterized by periodic wetting and drying, and there is a possibility of freeze and thaw depending upon the region where the structure exists. The surface in tidal zone are mostly wet with a limited access of oxygen. The extension of tidal zone varies approximately, ladies and gentlemen, from 0 meters practically to 15 meters as high as that. If you look at the splash zone is characterized by a randomly wetting and drying process. It of course depends on cyclic action of the waves. The extension of splash zone depends on the wave height at a specific sea state. It depends on what is the wave height at which the operational design has been done for the platform. It is also dependent on variation of tides in a specific sea state. The corrosion rate below the water level is limited by low oxygen availability, and conversely lower chloride and moisture content limits the corrosion rate above the high tide zones. Ladies and gentlemen, therefore, corrosion is most severe within the splash zone and the tidal zone where alternate drying and wetting takes place. This results in high chloride and oxygen concentration, which is one of the primary factor which activates corrosion in reinforced concrete, especially in concrete as a construction material for ocean structures. If you look at deterioration of concrete as one of the important event which is interesting for us to know what are those reasons why concrete should deteriorate under marine environment. For long term studies of Portland cement, mortars and concretes exposed to seawater, literature very clearly show that magnesium ion attack is well established by the presence of white deposits of magnesium hydroxide, which is also called as brucite, and magnesium silicate hydrates. So, research has been conducted on different white deposits which has happened on long term exposure to seawater, which clearly shows the presence of magnesium hydroxide or brucite and magnesium silicate hydrates. In seawater, a well cured concrete containing large amounts of slag or pozzolana in cement usually outperform the reference concrete. There is a basic reason for this. The essential reason for this is due to lower presence of uncombined calcium hydroxide which is there after curing of concrete. There is a potential loss of concrete mass by leaching away of calcium from hydrated cement paste due to carbonic acid attack, which is also important. The dissolved carbon dioxide content in any seawater is not a major concern for many chemical analysis, but that is one of the important reasons why there is a potential loss of concrete mass by leaching away. loss of material in concrete is associated with higher normal concentration of dissolved carbon dioxide present in seawater. So, that is one of the important factor why concrete presence in seawater has got loss of concrete mass by leaching away calcium from hydrated cement paste. If you look at deterioration of concrete further in detail, the presence of following are reported in the literature. They are responsible for deterioration of concrete in the marine environment: thermosite, which is calcium silicocarbonate; hydrocaluminite, which is calcium carboaluminate hydrate; and aragonite, which is calcium carbonate. Ladies and gentlemen, the presence of these three compounds in cement or on the surface of members exposed seawater constantly clearly show major reason and major concern for deterioration of strength of concrete and durability of concrete when they are exposed to seawater. We look quickly at the action of carbon dioxide and magnesium sulfate now in this slide. If you look at the action of carbon dioxide presence in deterioration of concrete, calcium hydroxide plus the presence of carbon dioxide in water forms what we call as a precipitate powder, which is calcium carbonate, which is a component of aragonite and calcite. They appear as a surface coating on the member which is wet. If you look at the action of sulfates, which is magnesium sulfate, magnesium gives you calcium substitution, magnesium sulfate plus calcium hydroxide forms a soluble leaching powder, which is calcium sulfate, which also forms a solid secondary gypsum, which is essentially responsible for expansion of concrete in case when they are subjected to seawater. Magnesium hydroxide forms as a precipitate which appears as a coating over the members on the surface. If you look at the action of secondary gypsum, calcium sulfate plus secondary gypsum in the presence of water or moisture causes what we call yttringite as a compound as an outcome of this chemical reaction. If you look at the action of chloride, which is also responsible for deterioration of concrete, magnesium plus gives you the calcium plus substitution. The magnesium chloride in the presence of calcium hydroxide forms what we call as a leaching compound, which is calcium chloride as well as magnesium hydroxide, which becomes as a precipitate powder which appears as a coating over the surface. If you look at the action of calcium chloride alone, which is responsible also for deterioration of concrete, then calcium chloride in the presence of moisture gives you chloroaluminates, further added to SO3 gives you what we call yttringite compound, which also results in thermosite compound, which are highly responsible for deterioration of strength and loss of durability of concrete in marine environment. Therefore, ladies and gentlemen, the presence of thermosite, hydrocaluminite and aragonite have been reported in cement paste derived from deteriorated concrete exposed seawater for long periods. The major deterioration was observed in the samples having greater thermosite. Several case studies are reported in the literature by researchers which show that the chloride profiles indicate a greater damage due to the presence of corrosion. This was seen higher on the surface of coastal structures presented in the literature. All these references relevant to our studies are available in the list of research papers advised to you in the website of NPTEL IIT Madras under the course of Ocean Structures and Materials. Now the question comes, as we understand concrete has a specific problem related to strength and durability, can we have some guidelines related to how do we select type of cement for ocean structures, because selection of important ingredient in concrete which is cement, which matters much in terms of its durability and strength. Let us see, can we have some guidelines by which I can select an appropriate type or quality or variety of cement which can be used in ocean structures. Researchers advise sulfate resisting cement which suffer less chemical decomposition in seawater when compared to ordinary Portland cement, which is referred as OPC in the literature, but still it is a debatable subject because which type of cement to be used effectively in control, because still the studies are not able to strengthen the appropriate selection of cement for sea environment. Calculated addition of pozzolana can improve the durability of concrete. Researchers have said that durability of concrete can be improved by presence of pozzolanic content provided the addition of pozzolanic content is properly calculated and then added to cement. So, this calculated addition of pozzolana can improve durability of concrete by removing part of free lime from concrete. It reduces permeability to a very high extent and at the same time protects the reinforcement to the phenomenal level. Many authors and researchers have shown that blast furnace slag cement, what we call as BFC, also can be used when well cured, resist the action of seawater, which is fairly well. However, blast furnace cement cannot be the only alternative cement which can be suggested for coastal structures and ocean structures. If you look at this figure, which shows me different areas where I can talk about the reasons why the corrosion or the deterioration of concrete takes place in the atmospheric zone, in the tidal zone and the submerged zone. Let us look at an attention of a single pile with the reinforcement schematically shown. The concrete cover and the reinforcing steel is what you see in the picture here. There can be a cracking which can be due to corrosion of steel in these zones, which essentially happens closer to atmospheric zone and the high tide zones. Cracking can also be due to alternate freezing and thawing, which can happen in certain Arctic regions where these structures are constructed. So, these are fundamental reasons why they have deterioration of concrete in atmospheric and upper high tidal zones. The physical abrasion due to wave action, sand and gravel and floating ice can be a reason where we see extensive corrosion or extensive deterioration of strength and durability of concrete in the tidal zone. When I talk about the submerged zone, the chemical decomposition of hydrated cement happens in this area. The chemical decomposition pattern can be resulting in carbon dioxide attack, magnesium ion attack and sulfate attack. So, in different regions, ladies and gentlemen, we can see that how the concrete strength and durability is deteriorating due to the corrosive action present because of the chemicals available in seawater. This is what we call biodeterioration. Instead of chemical degradation, a new name is available in the literature because this is present in the concept of biological degradation along with the chemicals present in seawater. Let us look at the main causes why this kind of deterioration happens. There can be physical processes which are responsible for this kind of chemical attack or this kind of strength deterioration. There can be chemical process which are involved in the strength degradation of concrete when used under marine environment. There can be of course biological process which are responsible for this kind of strength deterioration and durability loss. If you look at the physical process much closer, the photograph shows you here is the result of cracking, abrasion, frost and dicing salts which are appearing on the surface of concrete member as you see here. Chemical process can be resulting from acid attack, can be a sulfate attack or can be an alkali attack which forms a white compound or white surface on the surface area of the concrete as well as patches which is having brownish and white compound on the surface. If you look at the biological process, excessive marine growth are considered to be responsible element for strength deterioration of concrete in submerged zones in particular. Excessive marine growth can be as thick as close to about 10 to 15 centimeters, which improves the diameter of the member as well, which improves specific gravity and the weight of the mass of the structure, as well as it denies access to the concrete member for any inspection and repair. So, the photographs show you here are the marine growth or extent of marine growth which has happened in the submerged zones on along the column or along the pile of concrete members. Ladies and gentlemen, now let us look at the environmental factors that are responsible for concrete deterioration or loss of strength of concrete in due course of time when exposed to sea environment. If you look at, there are various conditions which are responsible for this strength deterioration. One can be the exposure conditions which are responsible for the strength deterioration, the varying temperature range which happens in sea environment and the presence of humidity which also alters from the atmospheric zone till the submerged zone is also responsible for corrosion and other deterioration effects on concrete in sea environment. Of course, the quality of water, the chemical composition, the biodegradable mass present in water in sea water in particular is also responsible for the strength deterioration of concrete. The aggressive elements which are chemical compounds present in seawater or the chemical compounds which are released during the drilling process etc., can also be equally responsible for strength degradation of concrete when used in marine environment. There are other causes by which concrete alone cannot be blamed for loss of its strength and durability. You can also have basic faults in design, and there can be some constructional defects which are also equally responsible for strength loss in concrete members when exposed to sea environment. There can be poor quality material which has been used in construction. This can also be an oversight, in particular when you talk about coastal structures. The reason is we are using massive concrete underwater, and quality control during concreting may not be that effective as good as what we do in land based structures. So, poor quality material can also be one of the fundamental reason why concrete degrades its strength much faster than land based structures when put under water. Above all, very important factor which people have now started paying attention more in terms of concrete structures in sea environment is inadequate supervision. When the supervision is not properly technically carried out for the construction of offshore and coastal structures, ladies and gentlemen, we must agree that this also lead to one of the important factor which degrades the function of concrete in marine environment. So, concrete as a material cannot be blamed alone for its strength degradation. There are many other physical factors, for example design fault, for example construction defects, can be poor quality material, can be inadequate supervision, there can be corrosion of reinforcement as well. Therefore, these are all added reasons or added causes which adds to strength degradation of concrete, especially in marine environment. There can be other technical factors which can also result to or which can lead to the durability problems related to concrete in marine environment. Here is a photograph. What you see is a corroded spillway which has been retrofitted with galvanic cathodic protection. So, we will talk about corrosion in detail in the following lecture, where we will talk about what is the corrosion process, what are the different methods by which you can protect corrosion. Ladies and gentlemen, as we all agree, corrosion cannot be prevented. It is very difficult because it is by inherently present in the sea environment. Of course, corrosion can be retarded, can be slowed down, or can be corrected, or can be protected. So, one such methodology which has been used for corroded spillway using a galvanic cathodic protection is what you see in this photograph. The next important feeling what people have in terms of improving strength of concrete or performance of concrete members in sea environment is type of inspection which can be carried out to constantly monitor the strength of concrete and the durability and its performance in the progressive manner and keep on correcting it before it degrades much beyond the accessible level. Visual inspection is a foremost red line in the inspection methodologies. What we do, we will be talking about this in the next module, that is module 4, where we will talk about non-destructive testing techniques in detail. We will also talk about various methods of rehabilitation and retrofitting of concrete and other type of structures in sea environment. There we will talk about these kind of inspection methodologies much in detail. So, visual inspection is the top red line talking about inspections. Cracking condition of exposed metal components can also be examined by different methodologies by which inspections can be done. The condition of foundation is a very important aspect where I can study to improve the performance of concrete under specific environment. The amount of marine growth, ladies and gentlemen, is a very dangerous phenomena where the strength of concrete members in particular is seriously affected because marine growth prevents accessibility to the deteriorated surface. Therefore, correction, inspection, other things cannot be done. If we talk about quickly a brief idea on repairs and repair methodologies of concrete, removal of deteriorated concrete is one of the important suggestions given by people and the researchers, which has been practically used in many of the marine and coastal structures. Sealing of cracks using different chemical compounds is also being attempted by various engineers in different capacities all over the world to provide or to improve or to establish a stable performance of concrete members, especially in sea environment. Replacement of concrete of course a good alternative, but is as expensive as constructing a new structure. So, rehabilitation cost of these suggestions can be even higher than the original principal structure. The surface treatment is a cosmetic repair what people normally do for attempting to these problems for a short span of time to improve the serviceability to a basic acceptable level. So, surface treatments can be vapor permeable coatings or vapor barrier coatings. I am not degrading the type of surface treatments being done by the practicing engineers to protect marine structures, they are all periodic maintenance. If these maintenance are done of surface treatment are done essentially when you want to improve the quality control of concrete or to improve the degraded concrete, is not a good idea. So, vapor permeable coatings can only allow you to give strength on the superficial side, whereas the internal integrity of these members would have been lost because of strength degradation. So, it is very important for us to understand what is the level of strength degradation before we go for any rehabilitation methods, which we will be discussing in the 4th module of this course on ocean structures and materials. People also talk about restoration of structures, where we talk about realkalinization and desalination. Talk about some of the field methods which are used for inspection and improving the strength and grade of concrete for marine environment. Schmidt-Hammer method is one of the important technique which people commonly use. In addition to that, people use portable adhesion tester method, people use galvanized pulse method and half cell potential measurements to qualify the suitability of concrete as is various basis, and then recommend appropriate treatments or appropriate methodology of repair which can be then practiced on these members with advice given to them by an expert technical board. Schmidt-Hammer method, I am sure engineers would have heard about this, civil engineers and structural engineers have used this method. It is a very simple equipment which tells me the strength on the surface essentially. Galvanized pulse method is another technique which can be used to identify the strength of the concrete. Half cell potential measurement talks about the penetration of chlorides which is responsible for corrosion of reinforcement, and of course exposure test before construction is a very practical method by which I try to keep concrete members in the same environment as they will be subjected to in due course of time. It is a very physical and practical method by which people generally do this for adapting concrete to the specific environment which they will be used later. In timber or wood, we call this a seasoning of wood. Similar to that, seasoning of concrete is nothing but exposing it before construction. Here is a photograph which shows you ordinary Portland cement member after 18 years and after 20 years. You see, within a span of just 2 years can see a lot of pockets of deterioration happening, a lot of surface repairs being attempted. So, ladies and gentlemen, with this slide we will be closing this lecture, where we are talking about concrete as one of the important material which can be used for marine structures and coastal applications. However, concrete has specific problems, degradation of strength and durability, which can be addressed by different techniques and methods. In the next lecture, we will talk about a new technique which a recent advancement happened in the United States, talk about crystalline method of strengthening concrete. Thank you very much.